Hi students, we're going to look at parabolas in a new form of those, and here are the general forms that we're looking at. If the parabola opens left or right, it's going to be a y. The y is going to be squared. It's not a function. Violates the vertical line test. If it opens up or down, it's going to begin with an x squared. And I don't mind if you mix these two sides up, as long as you make sure that this coefficient, the 4p, never goes on the side with the square. So this is an important part of that, because if you do, it's not 4p anymore, it's 1/4. So make this note, the 4p will always be on the side of the equation with a non-squared side. So let's look at this anatomy of a parabola. You have the parabola itself, the graph, and as you know, the vertex is right there, and on that same axis of symmetry, which your book calls the horizontal axis, which I hate, that's actually the axis of symmetry, your focus is on that same axis. So if your parabola opened this way and your vertex was here, the focus is here. If your parabola opened this way, the vertex is here, and of course the focus is here. So please understand the focus has to be inside that parabola, and the directrix tells the direction of the parabola, really which way it's going to continue, and it will never intersect that parabola. So, and the distance you have between the focus, this is not to scale of course, the distance between the focus and the vertex is called p. The distance between the vertex and the directrix is called p. And notice in your formula you need 4p. And we talked about the latus rectum. The latus rectum is actually this distance, a horizontal distance, if you go straight across and it's parallel with the directrix. And that's 4p. It's how wide the parabola is at this very, very special spot. But they don't really use it, but I want you to see what 4p is, why they talk about 4p. Alright, so let's do some examples. Given any two of these things here, you have to state the equation. So I'll begin with this. If my focus is 2, 2, and the directrix is x equals 5, then I'm going to draw that. So if the focus is 2, 2, be right here. Directrix is x equals 5, so that would be like right here, correct? And this tells me which way my parabola will orient. So if this is the focus, then I know that the vertex has to be like that, because it has to enclose that focus and not ever intersect that directrix. So now I know which way this parabola is going. So I know it's a y squared. So I'm going to start my equation by saying y minus 2 quantity squared is equal to x minus 2 quantity squared, because I didn't mean to do that. X minus 2, not squared, because only the y is squared. Only one of them will be. If both of them were squared, we're talking about a circle, and this is a parabola. Okay, so I need to determine the distance between the focus. Now I know between the focus and the directrix is pretty far, but that's actually 2p, right? I just need p is the distance between the focus and the vertex. So I can just find the distance between these two and divide it by 2, right? Because they are 3 apart. So 3 must be 2p, because these two are 2p apart. So 4p must be 6. And the last thing, it's negative, because when the y goes in this direction, it is negative. Notice that 4p is with the linear part. I call it linear because it's not squared. Okay, let's do one more. Okay, I made this one up. I hope I'm not sorry. So the first thing I do is write down what I'm given, the two things I'm given. The second thing I like to do is to draw this thing. Okay, so it's 6, negative 2. So let's 1, 2, 3, 4, 5, 6. So let's say it's about there. And if my directrix is y equals 4, that's up here, right? So this is y equals 4, this is 6, negative 2, and it's my vertex, so which way does it point? It must travel downward. And my focus is right here. But I don't really need that. I just need to know what p is. How far is it from here to here? So if this is where the y is 4, and this is where the y is negative 2, that distance, they're 6 apart, right? So that means p is equal to 6. Now I know up here I did 2p, but that's because I didn't have the vertex. I was looking at this p plus that p. Okay, so going back, if p is equal to 6, 4p has to be 24. And I'll figure out the negative positive in a second. So I'm going to say y plus 2 is equal to x minus 6 quantity squared, and it is negative, but remember it's not going to go over here. This stays all by itself. I'm going to make this negative 24. So it's negative 24, y plus 2 is equal to x plus 6 quantity squared. And there is my parabola, because it's x squared goes this way. Okay, you can tune out now if you'd like, or those of you who want one more, I will do one more. So here's my vertex and my focus. They'll always have one coordinate that's the same. So the vertex is at 3, 1, and my focus is at 8, 1. It's 3, 4, 5, 6, 7, 8, 1. So if this is the focus, this parabola must go this way. So let's find the equation. And I know this is going to be a y squared. So it's going to be y minus 1 quantity squared is equal to this big I don't know, x minus 3. So what is the p? What is the I don't know? To go, the distance between these two is 5, right? That's 5. So this must be 20. Again, notice that it's with the linear term. This coefficient is 4p, and that's great. Okay, I hope this helps. You guys take care.